I am going to talk about something called a property. And properties in math are a set of rules that are always true. Okay, so the property that we are going to talk about is distributive property. And distributive property will be useful for us when we are when we are combining like terms. Okay, so when we get to those upper level expressions that we need to add the like terms, distributive property is a tool we are going to use, okay, a strategy that we're going to use to combine like terms. Okay, so what is distributive property? Well, the best way I know how to explain to tell you what distributive property is to just show you what distributive property is. First of all, in your notes, go ahead and write down the words distributive property. Okay, and the first example that we are going to go through is 5, parenthesis, 6 minus 4a. 5, parenthesis, 6 minus 4a. Okay, well, first of all, why do we need to know what distributive property is? Well, in this example here, this example gives us a good reason of why it's useful. Okay, if you look inside the parentheses, okay, if we were to follow the order of operations, PEMDAS, which we talked about last year, the first order of operations is parentheses. So we have to do anything inside of the parentheses. Well, we cannot take 6 minus 4a because they are not like terms. We cannot combine those terms. And we can multiply, but we can multiply on the outside 5, okay, just like any other time when a number is right next to a set of parentheses. The operation is multiplication. So in distributive property, we are going to use multiplication to distribute the 5 to each of the terms inside of the parentheses. Okay, so I'm just going to draw a line in between the terms in the parentheses. So 6 is a term and negative 4a is a term, or minus 4a. Okay, minus and negative are the exact same thing. Okay, there's no difference between those two. So we're going to do what we call distribute. Okay, just like the mailman distributes mail. He gives you mail to each house, brings mail to each house, he distributes it. Okay, he passes out the mail. Or just like I distribute papers in the class, we're going to distribute the 5 to all of the terms in this, inside the parentheses in this expression. Okay, so I'm going to draw an arrow, and I want you to do the same thing in your notes as you take them. 5, and we're just going to multiply every time that we distribute something. So 5 times 6 is what? Well, 5 times 6 is 30. So we're going to write that underneath. Okay, minus 5, we're going to distribute again to the second term. 5 times negative 4a. Well, 5 times 4 is 20, and we don't worry about multiplying the a, we just bring the a down. So we've distributed 5 times 5 to the 6, 5 times 6 is 30, and 5 times negative 4a is negative 20a. So the expression is 30 minus 20a. Okay, let's try another one. Three times 2 plus x. Well, the first thing I'm going to do again is I'm going to split up the terms inside the parentheses. So the plus sign's there. So we have 2 as a term inside the parentheses, and x. X is all by itself inside the parentheses. Okay, that's the second term. Remember, if x is all by itself, the coefficient is 1. It's just understood. We don't write it because 1 times anything is just itself. So I'm just going to write in a 1 there, just so we know it's there. So I have my line, okay, plus 1x. Okay, it's 1x all by itself. So we're going to distribute. So we take 3 times 2. 3 times 2 is 6, plus, distribute to the second term, 3 times 1x is 3x, because 3 times 1 is 3, and we bring down the x. So the simplified expression is 6 plus 3x. Okay, let's try another one. Distributing these using distributive. Okay, now we have 4 times 12y plus 10. Inside the parentheses, split the terms up. 4 is distributed to the 12y. 4 times 12 is 48. Y. The y comes down. 4 times 10 is 40. So the simplified expression is 48y plus 40. Okay, let's do another one. Okay. Now, this is the same thing, except the 3 is on the outside of the parentheses on the right side. Okay, you're going to see this on Khan Academy once in a while. They might even put a time sign in there like that with the dot, the way that we show multiplication now. Okay, you can still distribute. Okay, if I split the terms up inside the parentheses, 3 times 2a, positive 2a is 6a, and 3 times 2 is 6, so this is 6a plus 6. That would be the simplified expression. Okay, we can also work backwards with distributive property, and they call it factoring with distributive property. So an example of that would be something like this. Okay, and this is where we're going to go back in time and think about how we found the greatest common factor. Okay, well, what you need to do is between 25 and 5b, you need to see if there's a greatest common factor. Well, if you don't know what the greatest common factor is between those, you can just do that by using our prime factorization method that we did earlier this year. So I will take 25 and factor it out until I get my prime factors, 5 times 5, and then I'll take the whole number on 5b, factor that out. Well, this is a prime number, okay, and then we decide which ones do they have in common. Well, they both have a 5, so we write it one time. They have nothing else in common. So the greatest common factor of 25 and 5 is 5. This is what we do with that. Okay, we write 5 and we put a parenthesis. And we say, what's 25 divided by 5? Well, 25 divided by 5 is just 5. Okay, what's 5b divided by 5? Well, 5 divided by 5 is 1. 1, and then we just bring the letter with. So it would be 1b. Do we need to write the 1? No, we don't. So it would just be 5 plus b, because 1 times anything is just itself. So we can just write that variable all by itself. So I'm going to write that so it's closer to the plus sign. So we factored out the 5 and did distributive property in the reverse order. Okay? If we were to use distributive property again to go the other way, 5 times 5 would be 25. 5 times b would be 5b. Okay, and these are the same. Let's try one more of those. Okay, so you look at the whole numbers in this expression and you have to figure out what the greatest common factor is. Well, I don't know the greatest common factor between 45 and 27. So what I'm going to do is I'm going to use prime factorization, or the factor trees, to do that. So 9 times 5, 3 times 3. Prime factorization is 3 times 3 times 5, and 27 is 9 times 3. Oops, that's not prime. 9 is not prime. 3 is prime. 9 we have to keep going. So we have 3 times 3 times 3. What do they have in common? They have a 3, so we write it one time, cross it off on both. They have another 3, write it one time, cross it off on both. They don't have anything else common, so 3 times 3 is 9. Okay, so the greatest common factor between 45 and 27 is 9. So we're going to write 9, parentheses. 45 divided by 9 is 5, e, because we take the e along, minus 27 divided by 9 is 3, and we bring the variable with 3f. So this is using distributive property in reverse order by factoring out the greatest common factor between the two numbers. Okay? Let's try one last one, and this will be an example that shows you how we use distributive property when we combine like terms. Okay, so we're going to write 5, 2b plus 3 minus 2b. Okay, so in this whole expression, we have two terms. Okay, and inside of the parentheses, there's also two terms inside those parentheses. Okay, so the first thing we need to do is we need to use distributive property. Okay. And we're going to distribute this 5 to the first term in the inside of the parentheses. 5 times 2b is 10b. 5 times 3 is 15, so plus 15. And then we're going to take this term down here too. Okay? The next step would be to combine the like terms in this expression. Okay? So we're going to split the terms up, okay, at its plus and minus sign, or addition and subtraction signs. And we're going to figure out which terms are like terms. Well, the first and the third term are like terms because they both have a variable. So we're going to take 10b minus 2b, and we get 8b. These go away. We bring down the last term, that's all by itself. It has no like terms, so we don't have to combine anything with it. So our simplified expression from here, where we distributed, all the way down to our final simplified expression is 8b plus 15. So if you ever see one that has distributive property, always do the distributive property first, get a long expression, and then combine the like terms on that expression. And you will get something like that. Okay, that's how we use distributive property. Okay, that's how we factor out numbers using the distributive property rule. And this is how this last example is how we use distributive property when we are combining like terms.